Hello, everyone. Thanks for joining us today. It's a great pleasure to have you all here. My name is Balaji Iyer. I'm a senior consultant with the AWS Professional Services team. I'm here today with Eric McKee. He's an infrastructure architect at GE. We have a great session for you today. Today's session is operational monitoring and alerting at scale in GE transportation. The digital footprint of a large global enterprise is immensely complex. It consists of digital assets that are globally distributed across private and public cloud environments. It consists of a variety of application and technology stacks that uses legacy and modern application frameworks, also distributed across several assets throughout the world. IT environments have many cross-functional interdependencies. Monitoring is a general first step that enterprises take towards getting control of their distributed, interconnected infrastructure. The goal of this session is to share our learnings, best practices, pitfalls to avoid, and provide you some design patterns to monitor and scale efficiently. Let's get started. In this session, we will start by painting a picture of the enterprise monitoring landscape and look at some of the operational challenges and hybrid cloud scenarios as it pertains to large global enterprises. We will then try to understand what cloud monitoring is and how it's different than traditional monitoring. Then Eric has got a fantastic digital transformation story to share from GE, and he will review the monitoring and alerting solution that was implemented at GE Transportation. We hope that you walk away from this session with reusable, enterprise-ready design patterns, which you can readily apply to your organization to monitor and scale efficiently. As enterprises migrate their workloads to the cloud, it's very common to bring their traditional tool sets to also manage their hybrid environments that is spread across their public and private clouds. This presents some unique challenges. Many of the traditional tool sets are not designed to handle the dynamic nature of the cloud. They oftentimes struggle to keep up in pace. Naturally, you end up creating two different environments and two different technology stacks, one that perhaps work well with AWS, and the other one maybe that work well with some of the on-premise infrastructure. When you do that, you don't get a single pane of glass view and have limited visibility across all your digital assets. Finally, many of these on-premise tool sets have licensing costs that can range from freemium to a fixed cost based on a number of servers. That can be particularly challenging because in cloud, all the resources are meant to be stateless, and they are not meant to be persistent for long periods of time, because they're meant to and designed to come up and down based upon the demand. Large enterprise customers have shared us that managing cloud and hybrid environments using traditional tool sets can be complex and costly. Let's take a look at how cloud monitoring is different than enterprise monitoring. Monitoring and logging can be challenging in many on-premise environments due to the manual configuration of physical and logical resources that can span across multiple isolated systems. So monitoring data, even when it's available, it's really hard to get full visibility across all your digital assets because they are spanned across multiple systems, and they operate at different procedures, protocols, and environments. On the other hand, cloud monitoring is very different. Changes to cloud infrastructure are tracked as API calls in real time. All the changes to your cloud infrastructure can be tracked and audited. And all the infrastructures are tightly coupled to events that are triggered based on various actions that are performed in the enterprise infrastructure. Based on all these reasons and more, The best monitoring strategy for cloud is a proactive strategy that detects problems before they have a broad impact on the overall system. So when we started thinking about what are the key characteristics of an ideal monitoring solution, the first and foremost, we wanted something that is inherently secure and improves our security and compliance lifecycle of our applications. And a lot of enterprises today, more so than ever before, they are challenged with reducing the total cost of ownership. So we were looking for solutions that does not have licensing fees and that does not have long-term licensing costs or contracts. Another key element of our monitoring solution is the ability to scale tens and thousands of servers with millions of different requests without adding any additional complexity or compromising security. As a general best practice, we want to make sure all the changes are being auditable. Another key element that we wanted to implement is we want to make sure we automate all the repetitive tasks. When you think about large enterprises, they don't have the luxury of putting a lot of resources just to manage and maintain their infrastructure. So we want to be able to scale with a handful of resources for a very large global team. So we wanted to make sure we can automate all the repetitive tasks so we can actually scale with a handful of resources. This enables enterprises to spend their cycles on higher value business problems that are more important and differentiated to their customers. Lastly, we want a unified way to handle your business infrastructure and your digital assets. So you don't think about whether you want to manage your hybrid infrastructure, whether they are in AWS or you're on-prem, or are they running Windows or Linux. It has to be seamless across these environments. It doesn't matter where they're located. Now that we have a solid understanding of the enterprise monitoring landscape, I would like to pass it over to Eric, and he will share the digital transformation story.
All right, thanks, Balaji. So I just wanted to say congratulations to everybody. You made it to 5 p.m. on Wednesday. We're officially over the hump of this very busy week. My name's Eric McKee. I'm an infrastructure architect at GE. GE is over 125 years old, and we do business in well over 150 countries. Our digital transformation is a major driver for IT at GE today, and part of that drive includes our drive to the cloud. In this presentation, I will specifically cover GE Transportation's digital transformation as it relates to monitoring and alerting in the cloud. We saw a lot of benefits during the migration to the cloud. This slide shows some of those benefits, like a 30 to 50% cost out for each application that we migrated to the cloud. We also saw increased availability with build automation that allows us to quickly replace failing instances. And we saw decreased downtime with things like auto-scaling and elastic load balancers, which allow us to replace instances while an application is live. And those are just a few of the benefits. While those are great, there were also challenges when we began operating at scale in the cloud. Let's look at some of the specific operation and scaling challenges. Like many of you out there, we were coming from a legacy data center environment where we had technology silos. And each of those silos had its own skill set, hardware, and vendors. And with each silo, there were also separate tools for things like performance and availability monitoring, and monitoring and alerting on compliance, security, and other standards. When we moved to the cloud, we had only one relatively small team compared to the legacy environments. And the team inherited all the silos because they could create all of those resources with infrastructure as code. But the legacy tools were distant, and they were not easy to integrate with. And they were owned by other teams. So what now? Our drive was urgent, and we moved our first apps very quickly. There was not much in the way of monitoring and alerting in the environment. The first apps that we moved were what you'd call easy apps. They were typically low risk with low data compliance needs. But as we began moving more critical apps, the gaps in monitoring and alerting became more apparent. Next, we'll look at some specific monitoring and alerting challenges. So cost was key. At GE, we're very cost conscious. And we considered the infrastructure and the software costs diligently. We also focused on capabilities. We wanted to keep the number of tools low, but still have the capability to manage across the various resource types. And third, but not least of all, was supportability. With our small team, we needed to minimize training on tools. We needed to automate out tasks, reduce manual configuration, and avoid platforms to manage so that we could work as efficiently as possible. Wow, look at that slide. That's really hard to look at. Balaji's team actually nicknamed this slide. They call it the grand piano. This is actually a slide from our gap analysis, and this is just part of the list of gaps that we covered in our final build-out. I'll break it down for you so you don't have to turn your head sideways to read that. And as I do, I'll touch on the major groups in the colors there. So the compliance group is in blue, and this includes things like local user accounts, security groups, antivirus agents, NTP, and OS image age. And then we have the service area, and this is in light gray, and this covers services like DNS, authentication services like Active Directory and LDAP. And the rest are infrastructure, like the network gateways, route tables, IP address pools, even CPU and memory on the instances. With those in mind, we'll talk about how we kept our velocity during this project. So after we had identified the challenges and we defined the specific gaps, we wanted to keep our velocity. And borrowing a phrase from the AWS principles, we wanted to keep a bias for action. To move fast, we had to keep a culture of urgency in our team in order to meet our aggressive timing goals. And we needed to empower everyone to act and make sure any failed attempts were learning events instead of blockers. We also kept everyone informed and made sure that we had training and skill development plans around the tools that we would end up using. And then we needed a fresh approach. No preconceptions or design assumptions built into the requirements. To do this, we kept our requirements clear and simple. This also enabled us to be more open to ideas. And in action, we took fast, small steps, made clear success criteria that we could make sure we either met or missed, and we recognized winners and losers, and we kept moving. During the design, we had 4 main focus areas. For reusability, we designed for function-to-function code reuse, and to make solutions that we could carry from business unit to business unit. For scalability, we had to ensure organic growth and cyclical demands could be met automatically and avoid any type of manual capacity management or planning. Under serverless, we did not want to manage platforms or servers in order to avoid maintenance tasks like patching and upgrades. And we wanted to keep costs low, if possible, low to zero entry cost with predictable cost growth, which could help avoid barriers to adoption of this design. Now I'd like to pass it back to Balaji to review the architectural components and services that make this solution secure, scalable, and reusable.
Thanks, Eric, for sharing the great transformation story at GE. We don't see a lot of 125-year-old companies around. It is truly remarkable how GE was able to reinvent itself over and over again many times. So when we started building the solution, we started a long list of things that we wanted to execute, as you can imagine. So the grand piano slide that Eric showed is like a miniature version of a giant spreadsheet. So that's kind of what we started with. As you can imagine, obviously we wanted to execute in a timely manner and optimize on those 2 key areas. So we decided to focus on 2 areas more so than any others, and we'll tell you why. Whenever you're monitoring something, it's always nice to get these alerts. Get these emails, notifications, texts, in various ways. Not that we're looking for more emails to read, but that's only going to create more work and management overhead. So we started with a different approach instead. We started asking, what are those events triggering these alerts? What are the root causes of some of these events that are happening? So we wanted to start fixing these issues upstream, at the root of the problem, close to where these are happening. One of the key aspects of any successful enterprise operational monitoring is to manage configuration drifts. Configuration drifts can result in unexpected systems behaviors and failures, So we wanted to build a system which detects configuration drifts and can reapply and automatically reinforce this approved last known good configurations in case of a drift. So what we did here, we defined our code and our policies in the form of a document. You could think of it as a compliance as code, or your policy as code, or last known good version of some of these workflows as code. In the form of a document, it is a systems manager document, which you can apply across the fleet of your digital assets in AWS or on your on-premise environments. Everything is controlled using a role-based access that is centrally located in your AWS environment. Systems Manager is an agent-based service, so we have these agents installed on these environments, so we can trigger some of these configuration policies onto these assets that are located. Doesn't matter where they're located, we can take those actions. Some of the examples are if there's an IP table mismatch, or there's an antivirus setting that needs to be updated, or somebody created these new users that you didn't know about, or changed permissions. All that can be identified and can be reapplied, so we can manage those configuration drifts optimally. One of the deliberate design choices we made early on is just to make the solution reusable and fully automated using extensible frameworks. I'll tell you what that means. It starts with defining a simple-to-use framework that lowers the barrier to entry for new folks coming in and using the solution, because we wanted to make sure this solution can be used in a self-service manner. That is really the only way we can scale with a handful of resources. For example, we didn't want some of the folks who are going to be using this solution to learn Python or Node.js or whatever language that particular configuration is written. So ideally, we decided to use data-driven methodologies to pass runtime parameters so we can extend the solution for a wide variety of use cases. So if you think about a large enterprise like GE, they have similar use cases that are spread across these business units. But the only difference, a lot of times, is really the parameters of those local environments. So by providing a pre-baked policy, pre-baked solution that they can use, or a configuration that they can apply, using these dynamic parameters, we were able to automate a lot of these use cases at scale. So next thing you know, the adoption kind of automatically will grow. It's important to consider automating your entire change management process, starting one policy at a time. By addressing these events at the root of the problem, you realize that you'll notice that you're optimizing the solution and the surface area a lot more efficiently. So for things like, how are you creating your golden image? Can we automate that image creation process? So to make sure we can have the policies and the security configurations, everything can pre-configured in that environment. Like simple tickets like fixing unreachable EC2 instances, resetting forgotten passwords, or creating a custom workflow. All of this can be automated using this framework. After getting a clear understanding of the specific areas that we wanted to optimize, we started looking into the architectural options that are available to us. It was pretty clear we don't want to be in the business of managing servers. So we naturally gravitated to AWS solutions that can scale exponentially with usage, where we don't have to think about capacity managing or capacity provisioning. Most importantly, we're looking for service architectures that has availability and fault tolerance already built in. So this helped us to not worry about AWS availability zones or managing the health of individual instances. Serverless applications in AWS are primarily based around one product of ours, which is AWS Lambda, which is a functions as service event-driven paradigm, which is written in one of the languages, Node.js, Python, Java, or C#. There are several variants of Node.js and Python we support. Basically, the architecture is pretty straightforward. You have an event source that alerts when a change in data state or endpoint or a resource state is triggered, that will trigger a Lambda function. And at this point, the Lambda function can pretty much do what you want to do. It can interface with other services, talk to storage endpoints, talk to different APIs, or call another Lambda function in that point. There are lots of different possibilities of what you can do with serverless today. And it maps really well for event-based monitoring, which is what we're trying to do. GE Transportation was one of the early adopters of Amazon's EC2 Systems Manager because it was really a natural fit to what we're trying to do. It's essentially a lightweight, agent-based service that can be installed on your EC2 instances, on your on-premise service, running Windows or Linux, including your AWS environment. This agent itself is open source in GitHub. Several enterprises, including GE, have examined that code and added that to a list of approved services and processes for their organization. This agent communicates securely with the systems manager service. At that point, you can execute these configuration policies which you define. And all the changes are tracked and audited. And the best part is there's no cost to use the service. So this was like super appealing for us. The core of a systems manager is a concept called documents. It essentially is a JSON file which consists of a list of commands or actions you want systems manager to perform. So the code itself, the policy or configuration document, can be stored in GitHub. We recently announced integration support with GitHub. Or the code can be located in S3, and you can start triggering your workflow based on that. You can think about extending that to a CI/CD pipeline where somebody checks in a code that automatically triggers some policy configurations and roll it out to all your digital assets. At this point, you have several options to execute this document. One of which is run command. It's an on-demand service where you can execute this document that you define. Several enterprises are actually using this methodology and turning off SSH and RDP to all their instances. Because you define your policy, anything you want to execute in your terminal or in your command line, you execute that through a document sent to a run command. So all these changes are audited and tracked. So anytime you want to see what configuration has changed, you have this timeline view on see when that was changed and what caused that particular configuration drift to happen. There are other services like State Manager, Patch Manager, and Automation. They support documents of different types. For example, you have a PowerShell document that you want to execute. You're not basically rewriting that code to work for Systems Manager. You're essentially wrapping that PowerShell as an automation document and sending it to the Systems State Manager service. And that would execute on your behalf. Or a shell command or a shell script that you want to execute, you can provide that to your state manager that will run on your Linux instances. Let's say you want to run for this particular policy for a subset of your assets. That is totally possible too. If anything that matches an auto-scaling group or a specific tag in AWS, you can execute those for those specific assets. So that way you can think about different scenarios where you have multiple policies for different application teams, different workflows. You can execute based on those specific areas using tags. Patch Manager basically helps you automate the patch management process. And automation is an automation document where you can provide, exposes you to a wide variety of use cases. There are 3 other ancillary services like parameter store, maintenance window, and inventory. Inventory helps you get an inventory of all the services and process and applications that are running on your digital assets across your fleet. And maintenance window is where if you have legacy environments, a lot of enterprises have environments that you don't want to touch them because they don't know what it does, but they're running. So you can run some maintenance tasks on that on a pre-configured time. You can feed in a document to execute it as part of that maintenance window. Parameter store is a way to store parameters that can be used across your AWS environment. You can encrypt it. All your secrets and passwords can be encrypted using a KMS key. So when we started with a simple run command with a document and using State Manager. That's only source services that we used when we started. But the interesting part about that is just there are so many other options that are available to us as we started maturing the solution, which was super important for us because we want to make sure this can survive for a long-term commitment and also adoption across GE. Now I would like to bring Eric back on stage to review these design patterns, which you can apply to your organization to efficiently monitor and scale. Thank you.
All right, thanks, Balaji. So far we've seen the challenges, the gap identification, our design focus, and Balaji just finished going over the AWS architectural components. Now I want to review 5 patterns for monitoring and alerting at scale in the cloud. Our hope is that you can take these patterns back with you and you can implement them at your site and get to take advantage of these designs. The first pattern is based on AWS System Manager and Lambda. System Manager was brand new when we started working with it. We began working with it just a few weeks after it was announced about this time last year. I would note that the AWS product team for System Manager was very receptive to our feedback, and they prioritized changes to speed our adoption. Now let me step you through this pattern. In this example, we will focus on using this pattern to validate local user accounts on EC2 instances. So in step 1, we have a System Manager document association that runs every 30 minutes on a group of instances based on a specific instance tag and value. Then in step 2, we have a Lambda function that runs every 30 minutes and looks at the latest association results. And in step 3, for associations that return a failure, we publish a message via SNS, and then we put a record to DynamoDB with the SNS topic, a timestamp, and the subscribers. We also have an option to call a Lambda function for remediation. The value of this pattern is when an agent is needed on the instances to provide information or functionality, as in this example when examining local user accounts. So we have this document set so it looks at the instance user repository, which is a password file on Linux in this example. And we filter out any accounts that are acceptable. We filter out any accounts that are disabled. And if there are any accounts remaining, those get flagged as an error. And we can call Lambda to either disable those or delete those. Other use cases for this include checking for the state of specific services on the instance. So we can look at things like the antivirus agent and see if it's installed and see if it's running properly. We can look at the logging to see if the logs are being sent to an external location. And we can use this to look at things like memory and disk. So we can check those out to see if they're exceeding a threshold or perhaps underutilized and maybe an opportunity to right size. We can also look at local configurations for things like time synchronization with NTP. So we use this to check that the correct time servers are in the configuration file and that NTP is enabled. The second pattern we'll review is based on AWS Lambda. It is similar to the first in many respects, but focuses on monitoring where no instance agent is needed. I will step through an example for examining security group rules and ensure that they align with our security standards. So in step 1, we have a Lambda function that is triggered. The trigger frequency can be chosen based on the sensitivity and response times needed. The Lambda function is set to send its activity logs to S3. Then in step 2, similar to the first pattern, we publish a message to SNS, we put a log record to DynamoDB, and we call a Lambda function for remediation. In this case, we would remove the non-compliant rules. The value of this pattern is for infrastructure monitoring. In this example, we looked at security groups. We can look at the rules that might open the resources to all IPs or all protocols, and that could expose the resources to the internet. We would, of course, remove those types of rules. We also use this pattern for things like network access control lists. We look at authentication services in our VPC to see if they're available and responding. So this is like Active Directory and LDAP. And we also use this to check our cloud gateway functionality to make sure traffic is flowing in and out of the respective network locations that it needs to go to. And we also use this for DNS services to validate that DNS is returning proper details about names inside the VPC and externally. The third pattern is based on Lambda again, and is a component of the earlier two. This pattern can also be used on its own. It creates a persistent log of the email recipients and messages from the detailed alerts that we send using SNS. Let me step through it. So in step 1, Lambda publishes a message to SNS using the AWS CLI. And then in step 2, Lambda uses an AWS CLI call to read the SNS topic details. I'll note that the SNS topic ARN is a parameter on each of our Lambda functions. And then Lambda does a database put to DynamoDB with the current topic subscriptions at the time of the notification, the body of the message, and the timestamp. Lambda is also configured in this pattern to send its activity logs to an S3 log bucket. The value of this pattern is to create a persistent record of the alerts published by SNS. The fourth pattern is based on CloudTrails and CloudWatch. So CloudTrails keeps a record of all the API calls in our VPC, and CloudWatch gives us the ability to set rules based on the types of actions and the details of those API calls. Now I'll step through this example where we're monitoring for specific IAM policy modification or deletion. In step 1, we have CloudTrails enabled in the VPC to record our API calls. And then in step 2, we have a CloudWatch event rule that immediately matches specific API action, such as an IAM policy modification or deletion. And in step 3, notifications are sent to our risk team for review. The value of this pattern is its quick alerting on specific API calls. In this example, we're looking at IAM policy changes. We also use this pattern for other things, like API calls to EC2, so we can look for something like a stop instance or a terminate instance. We can look at changes that might be done to our network gateways, our NACLs, route tables, and any other changes that we want to monitor. We could monitor security groups. We have some very specific security groups that we monitor in our VPC. And then the final pattern is based on AWS config. So AWS config allows us to validate resources against managed policies and take action with Lambda as needed. Let me step you through a pattern using an example of checking S3 buckets for public read ACLs. So in step 1, we have AWS config manager rule, which is continuously applied, looking for any public read access on our S3 buckets. Then in step 2, AWS config maintains a list of non-compliant resources. And in step 3, a Lambda function will periodically process the non-compliant resources for notification and remediation. The value of this pattern is to monitor resources based on managed rules. Some other examples of this pattern are verification of EBS volume encryption. We can also verify that bucket logging is turned on our buckets. And we can even check for specific tags on our resources to make sure we have tags like cost center. Now that we've covered these patterns, I will briefly summarize some benefits, lessons learned, and some future potential improvements we're looking at. So the solution, so we covered the challenges, we looked at the gap identification, we saw the design focus, we covered AWS components, and finally we just covered the patterns. Now let's look at some of the benefits. The solution is agile. Many monitors apply automatically to new resources, and new application enrollment takes just a few minutes. The managed services that the monitors are built on scale without our team having to do any resource planning. Costs are kept low as services that are either free or measured by the thousands or millions. A quick story on this. During the development, we once joked around that the emails we were sending and actually reading to implement these costs more to actually read the email than the monitor took over several months, and that's easily true. Then for reusability, the Lambda code was reused across dozens of monitors, and only parameters needed to be changed each time. The overall operations are simple, with no servers or platforms to manage, and only a handful of services to learn. So let's look at some lessons learned. We learned some valuable lessons. At first, we attempted to do application-specific monitoring, and we found that we would need a much larger team based on the variation we had in our application design and in the technologies that the applications are built on. So this was not a sweet spot for us, and there are many vendors out there who do a better job than we could at our size. Our SNS messaging method is too easy to unsubscribe to. This became obvious with large distribution lists and required training and auditing. We found the timing of dependent steps was critical for System Manager and Lambda monitors to be successful. Mismatches led to either double alerts or, even worse, missed alerts. And repeated notifications became noise. We added a cooldown capability to our Lambda functions to alleviate this issue. And then looking forward, these are our top items from our backlog. We're looking at leveraging AWS step functions, which could improve some of the monitors and remediation that require a series of dependent steps. Step functions will allow for a series of functions in the remediation logic, and it offers opportunity for logical branching and passing inputs and outputs between the functions. For messaging, we're looking at improving notifications with something like a Slack or HipChat integration. And we're also looking to improve the Lambda code and the System Manager document management with a CI/CD pipeline. And around incident management, we plan to automate ticket creation in our ITIL platform, which was enabled by a recent ITIL platform upgrade. And last, we want to do more around self-healing and remediation, including terminating and rebuilding the application instances. We think this is a sweet spot where AWS step function would work well. So with that, I want to thank you all for spending this time with us. We hope that you find this information useful and take advantage of these capabilities. Balaji and I will hang out up here near the stage afterwards if you have any questions. And please remember to complete the survey and enjoy the rest of your time here at reInvent. Thank you.